We're going to now turn to permutations and combinations, which are certain groupings of objects. Excuse me, permutations. Permute means to reorder, so it really is caught up with the idea of order. A permutation of n distinct objects is a linear ordered arrangement. Sounds like a string in some ways, yeah, of the n objects. So it's just some ordered arrangement of the specific n objects. An R permutation of a collection of n distinct objects is a linear ordered arrangement of R of the n objects. So we're restricting our attention to choosing R of them. And the symbol PNR denotes the number of R permutations of n distinct objects. So here these permutations, as we're talking about them here, there is not repetition allowed. It's truly permuting R specific objects chosen from the n objects. So I'll say right here, without repetition. That's implicit in our understanding of a basic permutation. So the first thing we're going to do here is just list some permutations of A, B, C. That just means to take those three things and order them all the possible ways there are. So that would be A, B, C as we're given, or we could do A, C, B. Those are the two that start with A. Let's do the two that start with B. B, A, C, B, C, A. And then the two that start with C would be CAB, CBA. So there's 6 of them, and we could have figured that out, right? I mean, there's 6 of them because there's 3 ways to pick the first one. The number of them would be 3 ways for the first one, and then since we're not allowing repetition here, we're just ordering them. There are 2 ways for the second one and 1 way for the third. So yes, lo and behold, there are 6 of them. But here I was actually listing them all to see how they are, how they work. So what I'd like you to do is pause this video and list the 2 permutations of ABC. Remember, the 2 permutations, we'll do 2 of them at a time, so AB is one of them, but there are others. So take a second and do that. Pause the video and do that. Okay, if you're back here, I'm just going to scroll down here because I've listed them right there at the very bottom there. AB, BA, AC, CA, BC, CB. 6 of those as well. So now what I'm going to do is list the 3 permutations of ABCD, and this will take a little bit more time, so I mean, you can try that and pause it and do it if you like, but I'm going to go ahead, assuming you're back with the video now, and just lift it up here. And in this case here, there are actually 24 of those. You can see that if we did a slot argument, we'd have whoops, not that, because it's 3 permutations right there, so there's only 3 that we're taking at a time, but there are 4 choices here first, so that'd be a 4, and then 3 for the second and 2 for the third, giving us 24 total. And in fact, there are 24 right there. And you could organize these in different ways. I've organized them in a particular way that we're going to use when we come back to it in just a little bit here. I will point it out to you though. Notice that if we look at this here, that these right here are all the same group of letters ABC permuted. These right here are all the letters ABD, and the 6 different orderings. These right here are all the letters ACD ordered, and these are all the letters BCD ordered. So I've arranged them that way, and that will have some meaning based on what we do later. So let me go ahead and talk about just permuting 5 distinct objects. How many permutations of 5 distinct objects are there? So this really is like a string of the 5 things. It's just that permutations and combinations are a category of arrangements that are talked about in this way. So A, B, C, D, E would be a nice way to think about it. How many different ways are there? Just to reorder those, it'd be how many ways can you put these in an order of all 5 of them? And we did that problem actually in our last in-class set. So the first one, there are 5 choices. The second one, there are 4, and then 3, 2, and 1 for the 5th one, or that product right there, which is 5 factorial, right? In fact, let's talk about factorial. For a positive integer n, the factorial of n, denoted by n factorial, that notation, we read it n factorial, is the product of n minus 1, n minus 2 to 1. It's the product of all of the positive integers from 1 up to n, just like we have above for 5 factorial. Separate, we define 0 factorial to be 1. That's because it's convenient in the expressions we use, and makes the formulas that we develop valid even when there's the 0 occurs in the formula with a factorial. An alternative way of thinking about it is if you multiply by something that doesn't change the number, the multiplicative identity is 1. Multiplying by 1 doesn't change it. And so multiplying by 0 factorial, or 0 factorial is simply 1. Okay, so here's some questions about factorials just to get you used to them if you're not already. If you have a non-negative integer, then what is the integer n plus 1, that's just one integer, times the factorial, n factorial? Take a moment, maybe pause, think about it. So what happens is this, of course, is all the integers n minus 1 down to 1. And this adds n plus 1 there. So, in fact, that is just n plus 1 factorial. Got to put the parentheses there. Second question, write 7 factorial over 3 factorial as a product alone. Well, you could write out the whole factorial there and see how this is working. It's worthwhile to see how this works out. So here we'd have 7 factorial over 3 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And the 3 times 2 times 1 cancels, just leaving us with 7 times 6 times 5 times 4. So it's the factors on the top, but only from 4 and above. We're going to talk more about this and develop a formula for the permutations in the next video.